Good morning, everybody. As I mentioned, I'm Brandon Krumwiede with NOAA's Office for Coastal Management, physical scientist, and I serve as the Great Lakes Regional Geospatial Coordinator, covering the entirety of the Great Lakes region. And so I know this presentation is probably going to be a little bit off because everything so far has been terrestrial. We're going to actually go a little bit in the water for this presentation. So what I'm going to talk about is our project that we're working on. It's been a multiple year project. Since we're all GIS folks, I figured we'll dive a little bit into the data as well. And then with that data, what are we doing, right? Cool, you're doing all this data collection, but what's the so what about that as well? So I'll talk about some of the Benthic data and its uses and share what's next on the plate for us as well. So, of course, you may all be thinking, well, wait, how's this all related to Wisconsin? And hopefully I don't have to remind you that there is a huge chunk of Wisconsin that goes out to the middle of Lake Superior here. And our interest is actually collecting high resolution bathymetry for as much of this as possible. When you think about it, and I'll put some contours on here for reference, the western arm of Lake Superior over along the Minnesota shoreline, that is one of the deepest portions at over 280 meters deep between Split Rock and Tattagouche State Park. But there's also a huge interest right here off the Bayfield Peninsula and the Apostle Islands, given the complexity between the islands themselves, the peninsula, and then, of course, some of the past geological and geomorphological activities. There you can see some of the deeper trenches actually between the islands here as well. This area is also a high priority. In 2022, we created the Great Lakes Spatial Priority Study. For those that remember this is where we ask questions about what type of data would you like to see collected in the waters? And lo and behold, this area was one of the top hotspots across the Great Lakes region as a whole. And so each of these grid cells is weighted based off of user response. For folks that had the fortunate opportunity to work with Michelle Wheeler or alongside her, she helped to lead a lot of the effort to make sure Wisconsin was well represented on that survey. And so because of that, we have been working quite heavily around the Apostle Islands for many years. And in fact, it led to the formation of the collaborative benthic habitat mapping in the nearshore waters of the Great Lakes Project. Again, being JLRI, we always seem to like long titles for our projects. But the goal here is actually to work collectively and do benthic habitat mapping. And so, the so what really starts here. The nearshore areas of the Great Lakes are very dynamic, as we've all experienced with changes in water levels. It's also the areas of highest productivity and greatest biodiversity when we think about the fish species that are in these areas. There's also that coastal connection when we think about human connectivity. We directly interact with that nearshore area, and it directly interacts with us when we think about coastal erosion and bluff erosion. For natural resource management, we're always looking for better data. And so, of course, a lot of the bathymetry prior to this work dated back to the 1970s, 1980s, and it was pretty coarse resolution data at that. And so we wanted to make sure that we had started to work to fill in with high resolution data. The other thing is, this is a very challenging environment to work in, especially in the Great Lakes. We have a very limited field season. Dealing with ice, and again, how ice changes around, we may be able to go out in April and start doing survey work, or we may have to wait until early June, depending on how much ice is still present out in the lakes. Our salty shoreline friends, they can be out there June, July, August, September, December, even surveying in Alaska up in November, December timelines. And of course, the other thing that's really cool is with the high resolution data, we're seeing a lot of interesting features. This example here, actually, we were talking about the differences in digital elevation models. This is actually taking two LiDAR bathymetry surfaces and creating that difference. And so any place that you see in red is actually where erosion has occurred along the shoreline here. And then, of course, any place that's blue is where deposition is occurring. And so you can actually see where that relationship between coastal erosion and this littoral sediment train, all that sediment starting to wash down shore here. This is actually a water intake pipeline that you see running here. And of course, with those currents, you can see the downstream scour, basically as that water flows over that, it's causing scour there. And what's really interesting is This feature that you see here is actually a roadbed that was present in the 1970s off of the Illinois shoreline. It is now sitting in about 10 feet of water. And so that's just how quickly, I said, 1970s, that was above the surface. Now it's 10 feet below the water. That's how quickly things are changing along the Great Lakes shoreline. And of course, this isn't just NOAA doing this work. We have a lot of partners. In fact, a lot of parts of NOAA itself are engaged on this project. But one of the first federal partners that worked with us is actually Jay and Brenda from the National Park Service, saying, hey, come work at the Apostle Islands. Great, we'll be there. Let's get data collection underway and build off the existing work they had done previously in the early 2000s and 2010s. We've also been working with the U.S. Geological Survey. Just recently, the U.S. Fish and Wildlife Service with their Green Bay office and their office in Lake Erie, they're helping out to do some of this work. And then, of course, working with the various departments of natural resources, Michigan, Minnesota, and Wisconsin. To date, we've been primarily focused in Lake Superior, Michigan, and Huron, but we are starting to expand down to, like I said, Lake Erie and Lake Ontario. And then on the academic side, working with Michigan Technological University as well as Michigan State University in this work. Our focus is 0 to 80 meter water depths, collecting high resolution bathymetry of at least 2 meters, if not higher spatial resolution. And then, of course, if it's multi-beam, we collect backscatter. That's how the sound is actually interacting with the substrate, or LiDAR reflectance, what the composition, and both of those help with the composition of the substrate. We also throw a bunch of equipment overboard, including drop cameras. I'll show a couple of pictures of that in a minute, as well as using ROVs and autonomous underwater vehicles to collect data as well. And then, of course, ultimately, all this data gets fed into the development of these benthic habitat maps and the products. And we use CMEX, which is the Coastal Marine Ecological Classification Standard. And we're mapping everything at least to a 10-meter spatial resolution. And so when you think about that, 0 to 80 meter water depths, we're looking at over 126,000 square kilometers. So anything highlighted in orange here is where our focus is. And if we bring this closer to home, as you can see, pretty much everything around the Apostle Islands is of interest to us, and going all the way out to the state boundaries here as well. And so you can see, of course, over by the Twin Ports, but then also Chequamegon Bay and east of the Madeline Island area there. We've got a large geography to cover. So CMEX, I'm not going to spend too much time on this, but basically, when we think about land cover, or again, forestry, we have our various classifications. And so when it comes to mapping in water, we use CMEX, the Coastal Marine Ecological Classification Standard. It is a Federal Geographic Data Committee standard that was established in 2012. But basically, for this project, we are focused on the geoform component, so actually mapping out landforms that are in the water. It's not just flat blue out there. There is a lot of complexity. And then, of course, the substrate, whether it's sand, silt, clays, and then more importantly, too, since this is GLRI, we're also looking at the biotic component as well. Things like mussels, zebra mussels, mapping out the distribution of that, or filamentous algae. Cladophora, for example. We've been doing a lot of the work there with the Sleeping Bear Dunes folks on that. And so a project this scale, there's multiple different phases. Phase 1 is basically where hasn't data been collected. So that helps us with mission planning. And then, of course, we go out and do the data collection, data set development, and data QA, QC. All that then turns into phase 2, which we do spatial modeling. Like, does this make sense that it's classified as sand or silt? We start to characterize it, and then, of course, create those mapping products. And once we have those mapping products, it's really important for us to turn around and make that data publicly available through data distribution and data discovery. All right. Quickly, we do, like I said, bathymetry starts initially with airborne LiDAR. We try and collect as much of the area as possible. This is an example in eastern Lake Superior. So we use Bathy LiDAR, which is 532 nanometers. So if you look up at an aircraft flying Bathy LiDAR, it's going to be a green laser that you're going to see shooting back down at you. That green laser is actually what allows it to penetrate into the water and reflect off the bottom. And so on the left here is actually the bathymetry off of eastern Lake Superior over by Bay Mills. And then what you're seeing actually on the right is the LiDAR reflectance, basically that light intensity as it reflects off the substrate. So areas like this that are a little bit more bright typically indicate like sand, white sand. Anything that's darker is either deeper or is a darker substrate in those locations. And of course, that's why we go out and do validation after the data collection just to confirm the results from this work. And so this is just one example off of Southeast Washington Island. This was the bathymetry prior. So this was all we had for soundings. Every little number here, that's where an old lead core single sounding was taken. And of course, then we come in with bathy LiDAR. And of course, we're getting both the terrestrial side. And so this blue line actually indicates the water's edge. So we get the terrestrial as well as the bathymetry here. And what's really interesting is you can see this red box to show you the level of detail as we zoom in. You can actually see the glacial scouring on the bottom of the lake here. And so this is what's really cool is what used to be just white with a bunch of numbers actually has a lot more complexity present. And so this is the type of new reef structures that we are starting to map out across the Great Lakes region. For a lot of the work that we've been doing now around the Apostle Islands, we're collecting through multi-beam sonar. So the RV Echo, which was actually the vessel owned by the National Park Service, is now a part of the NOAA fleet, together with the RV Swath and RV Laurentian. These are the vessels that NOAA GLERL have been using to collect multi-beam data for this project. We've also been able to bring in the NOAA Office of Coast Survey navigation and response teams. These are usually deployed to like the Gulf or the Atlantic seaboard. But prior to hurricane season, we have been able to get them up here and survey for about 30 days every season for the last 3 years. And this is actually new bathymetry off of Wisconsin Point. And so, again, what's really interesting here is if you've been to Wisconsin Point, you know, the water's pretty turbid, don't really think too much about it. And especially when you look at the charts, it's just pretty smooth. But there is actually a lot more complexity out here. We're seeing things like glacial eskers out in the water. And so that's what's really cool is all the new features that are being mapped with this work. And so prior to 2020, this is what the existing bathymetry looked like. And so a lot of this, of course, like I said, the National Park Service did collect multi-beam data kind of in between the islands. We had some past Army Corps of Engineers topobathy LiDAR. So again, they fly along the shorelines, get about 500 meters of the shoreline and 1 kilometer off of the shoreline. So that's what this lighter blue color is here. And then again, anything that's kind of green is some of the National Park Service data that they've collected here as well. And so as a proof of concept, we asked for funding to say, hey, can we just pilot a small geography and do this data collection and processing work? And the very first one was right here off the Bayfield Peninsula. So in 2020, we collected about 32 square miles of new high resolution bathymetry at 2 meter spatial resolution. Then in 2022, we collected off of Eastern Madeline Island and also off of the Gull Island Shoals. We were hoping to start using some autonomous data collection platforms. So we were hoping to work with Saildrone to come in and actually see if they could collect on the shoulder season. And so we had put this polygon north of the Apostle Islands as a potential collection liability. So Scott, I know you and I were talking about drones, and you know, when you have only one of them, Saildrone wasn't too keen on using one of their vessels to collect, especially near winter months. And so ultimately what was proposed as a survey collection using autonomous technology turned into a crewed data collection. However, I think we did a good swap here because we were able to then fill in and collect 198 square miles of bathymetry in between most of the islands and expand the bathymetry coverage around the Apostle Islands. And so again, everything that you see on screen here in those rainbow hues is at a 2 meter spatial resolution. And so I actually just handed off the drive to Al. He's now got a copy of all this data. And so that's where, again, working in partnership with our federal partners, the team is actually now processing. This data has all been processed, QA/QC'd, and should be made publicly available relatively soon. So after we go in and do the bathymetry collection, we follow up with the field data characterization and field ground truthing pieces. And so, like I said, it can be anything from drop cameras here, as you see I'm in holding. Literally, we just drop this thing over the edge. It goes down to the bottom, starts collecting video, and we use that video, and I'll explain here in a minute. We are using AI to process all those video feeds. We also use ROVs. Here's Hayden from Michigan Tech. And they do ROV work, especially on sites that are particularly of interest. And then working with USGS and their autonomous systems, they deploy the IVER systems, and that's doing underwater imagery collection as it flies a transect across the bottom. So you can think about it as like aerial photography, just underwater photography, and creating these really cool three-dimensional structure for motion point clouds from all that imagery as well. So this summer, you may see vessels running all over the place around the Apostle Islands. We're looking to collect over 700 sample sites have been identified. Now, not all of these are going to receive all three of those technologies. Some of these will be drop cameras, some are Ponar grabs, some are the autonomous underwater vehicle data collections, and then some of those are also ROV sites. And so this is where we work with local partners. And for example, we've been working with Redcliffe and TNC to identify additional potential sampling sites that support some of their fisheries work. Jay Glace, we've even reached out to him with his past work as the fisheries biologist for the Park Service to make sure that we're collecting in proper locations to inform this work. And so as I mentioned, sorry if the GIF here causes any motion sickness, but basically, we take all that underwater video and we use both a web-based platform called Tater to annotate the imagery. So, yep, rock. But now with all this annotation, we can actually start to go through and, as you can see, do object-based segmentation and classify every single boulder. Like, okay, identify all cobble, identify all boulders based off the size of the rock. And so now we can not only say, definitively, like, yes, this is a cobble field, we can start to quantify this as well. And so what's really interesting is the technology you're seeing on screen here. Anybody hear of deep sea mining or deep sea hard rock mining? This same technology is being used to identify metallic nodules out around American Samoa. And so some of the deep sea mining applications, this is where some of this work has started. So cool science happening in the Great Lakes being applied elsewhere around the world in that regard. But, that's well and great that we collect all this data, but it's more important to us that we turn around and make the data publicly available as quickly as possible. And so I mentioned all the topobathy LiDAR data collection. That gets served out through the NOAA Data Access Viewer. And so I don't have time, I think, right now, but this presentation will be shared out. And if you click on the image, it is interactive. It will take you to the Data Access Viewer. We have imagery, we have land cover, but then under this elevation tab, that's where the topobathy LiDAR data exists. In regards to the conversation about Amazon Web Services, all our LiDAR data that you access there will point you to S3 buckets for download. In addition, all this cool data that we're collecting, the mapping products, the underwater video, we are making that available now. This just was publicly released a couple of weeks ago. The NOAA Benthic Data Hub is an ArcGIS hub site where you can go in, see all the different project areas. And for example, that Western Bayfield data is publicly available. Here you can see the substrate classification. But again, we have pop-ups, and within those pop-ups, the video points, if you click that on as a data layer, you can click on those and play the video. And so this is really helpful for future scientists that may be coming back to revisit these locations to see what the substrate was. And I didn't capture it here, but we even had the percentage of substrate coverage associated with each of those sites as well. So what's next? As I mentioned, we've been doing some data collection over by the Twin Ports. So off of Wisconsin Point and Minnesota Point. This is all new bathymetry that's been collected between 2023 and 2025. As I showed, there are some really cool features over here off of Wisconsin Point, but I want to bring your attention up here. We have this long linear feature, have no clue what it is. Not on any of the previous nautical chart maps. It's over 2 kilometers long, so it's not like it's something man-made. And so this is definitely some of the new geology work that we're working with. Large Lakes Observatory, University of Minnesota Duluth, and other USGS as well to kind of figure out what these new features are. If you want to follow along, we do actually have the Great Lakes Collaborative Benthic Habitat Mapping Project dashboard. So this is an ArcGIS Online dashboard where we actually provide this specifics of like what data is publicly available. So anything in bright shades of green, that's data that is publicly available. Anything that's yellow or orangish in color here, That's data that's in progress, whether it's actively being collected or it has been collected and is just undergoing final review before public release. But for us, we're really using this to also inform EPA and GLRI about our progress on the project as well. So again, here you can see, for example, total nearshore area for Lake Superior is over 11,000. What has been acquired is just over 3,000 for 0 to 80 meter water depths, and of course, about 27% of that area. And then again, we are continuing to revise and use newer tools, things like geomorphons, which is a new package available in ArcGIS Pro, to actually go out and autonomously classify, or through computer vision, classify what else is out there. So you can see, for example, these rock fin structures. This is up off of Minnesota's shoreline. And you can see how that actually comes out as either a valley or a ridge line. And so this is helping us with some of the in-water landform classification work. So with that, I'll see if there are any questions. Al. We did that just along the mainland, and then keeps all the shallow areas. Yeah, so let me go back to this one here. So yeah, the blue here, sorry, I got these colors mixed up. This shade of blue, and again, working with Noah, we just love our shades of blue. This is actually the National Park Service multi-beam surveys. This darker blue is that older 2009 Army Corps of Engineers topography LiDAR data. This lighter blue is the 2019, and as you just pointed out, they never went back out and around the islands with that 2019 data collection. And we have, Army Corps is supposed to be coming back in 26. They were supposed to come back in 25. They always keep getting pulled to hurricanes. Like I keep telling people, we need to have a hurricane in the Great Lakes so that all the mapping resources come up here. They always say, right, have a disaster. That's when all the money comes. And so, yeah, unfortunately, we've always been at the lower end. But if there is interest from the Park Service, we can definitely start to put it forward as a potential future data collection and coordination. Yeah, I would say like now that we've got this as well, we've done a pretty good job of mapping out everything. The challenge, of course, like working here, especially in Lake Superior, as you can see, depending on water conditions, like the 2019 did get out here pretty far, but that was because there wasn't a lot of turbidity. Unfortunately, that's one of the downsides of topography LiDAR. If you have very turbid water, you're not getting any returns whatsoever in that regard. And so you're stuck to going back to a vessel data collection using traditional multi-beam. Yeah, yeah. I remember talking with Jay and Brenda about like, yeah, unfortunately the jurisdiction limited how far out the Park Service could do their multi-beam survey work. And so we're like, well, we don't have that jurisdiction. We'll just go fill. And that's the intent here. So. Yeah, I was I was debating about throwing in for folks reference off of Michigan Island. There's a really cool feature here. We actually have underwater landslide complexes off of Michigan Island. So, prior to that, this is what the bathymetry looked like, and so you just see like one sounding right here. But now, like I said, you have a sounding every 2 meters with this multi-beam data set, and so yeah, we've got landslide complexes. Some additional glacial geomorphological features are present out there as well. And then, of course, the other thing is like off of what we did over here with Parks Point and this complex, this was previously all just mapped as like hard substrate. That was it. But when we actually went down there And let me go back to this. So right now, this is, coarse unconsolidated substrate, some bedrock, and then fine. Most of this out here is actually fine unconsolidated substrate. So more of the silty clays and things like that. In fact, I was trying to click around and find video points like this one out here in deeper water. If I play the video, it goes down and it's just a plume of sediment. Whereas like this one now up around, this is Eagle Island Shoals, I believe. Yeah, some nice cobble. If you're a fisherman, here's all your great data to plan your next fishing excursion for sure. So
Quick question. I think in an earlier slide you had shown, I feel like it was over by Sault Ste. Marie, where some of the LiDAR work was slopping over onto the land. And here I'm like a bad date who just wants to keep talking about himself and like, oh, I do. So pulling it back to the land. Sorry.
all good.
Okay.
I'm coastal.
Okay. Yeah, sure. I've been really interested in like detecting water on land. And my understanding is that most terrestrial LiDAR, the points just bounce off and they're gone. So is there any application of, you said it was like a green beam, this bathy LiDAR stuff? Has any on land worked, like ephemeral pools, stuff like that?
Yeah, so the green LiDAR actually does collect on land as well, and it reflects off. So, terrestrial LiDAR is near infrared, so that's why you can't see it. But yeah, what happens is the near infrared LiDAR is actually absorbed by water. And so that's why you actually have no reflectance, no return. It doesn't actually bounce off, it's absorbed in. Whereas the green band, because it is a higher energy level, it penetrates down and can reflect off that bottom. Certainly, actually, there's a data collection, and let me see, how are we doing on time, Heather? I don't want to. Okay, so let me go ahead and show, because so let me go ahead and launch this really quick. All right, so elevation land LiDAR data. I'm going to go to an area I know pretty well with this. But to your question specifically, South Manitou Island, I know that there is a lake on the island itself. In fact, Florence Lake right here. And if I go click topographic LiDAR here, so this is I'm just going to demo the tool really quick. We actually have a 3D viewer as well. And so you can go ahead and click on, here's South Manitou Island, there's Florence Lake, and those points that you're actually seeing are the lake bottom there as well. So so you can see the tree canopy, and then of course the shoreline, and it's not a very deep lake. But yeah, those are our bathy points for an inland water body. And so USGS is actually looking at using bathy LiDAR to fly streams, lakes, things like that. The biggest challenge is making sure that the water body, especially for us in northern Minnesota and northern Wisconsin, we have a lot of organic material at the bottom. And so it's dark in color, which that means it absorbs that green band even, and you don't get a lot of good reflectance or returns. Just happens to be that Florence Lake here has a nice sandy bottom, and so you get good bathy returns off of those types of inland lakes like that. So if you know your lake has a nice sandy bottom and good water quality, there's a good chance that you could collect the entire lake with bathy LiDAR. And then again, you also do get green LiDAR returns off of vegetation and the ground as well. It's just, they get added into that near infrared point cloud classification then. Yeah, great question. All right, I don't want to keep people from lunch, so thank you, everybody.